Start recording, okay. And then share screen. Where is my, okay, I need to get this off. Okay, so today we will discuss note 5, okay, regarding the case study. So this is about 2012 Federal Election Commission database. So they have a CSV file. So as usual, we just import the CSV file that, and here it give you some brief description about the file that, so here it, so if we take a look, so here it lists the data columns, but this is not too clear. That a lot of time, if you recall, we can just do header, is it to get a glimpse of the data. So here we get the top 10 records from that data set, and you can kind of, so it's regarding a presidential election that, so here it's some, it's a committee or something ID anyway. So this is candidate ID. This is candidate name, okay, presidential candidate name. And this is who contributes, so contributors name, okay, so you donate money and they have some record here, okay, and your other information like your city, state, zip code, your employee, and let's see, I need to get, and the occupation, and the money donated and donate time, and some description, etc. So anyway, so here give us some glimpse of the data. Okay. And here, if you wanted to get some specific record to take a close look, you can also do, if you recall, the iLog. This is faster, etc. Okay, and here it also gives you quite detailed information, but you can also notice some fields here. Is it the value is net values? Okay. So anyway, so this just because whenever you start to do data analysis, assuming that the data set you have no idea, that so you need to kind, especially if the data is huge, that you have no idea, then you need to kind of glimpse the data to have some idea about the data. And then what next one, it interested, because if you recall, if we take another look at this is about 2012 presidential election, is it? So so the third column it gives is the presidential candidate name, is it? And here you can also find, is it? There are a lot of repeats, is it? So maybe you want to know, okay, for this candidate, is it like totally how many people contribute, made a donation to this, to his or her campaign, is it? And total how much money they received, some information like that, is it? So over here, that's why here you want to get all of the candidate name, is it? And so you can get that column, do the unique, is it? And then to give you all the candidate name, they are unique, is it? Okay, and after this, and if we glimpse the data, especially like for this specific record, you can see, even though you know candidate name, is it? But there is no party association information. in the data, as if you take a close look. But a lot of time, because generally speaking for US, we have Democratic and we have Republic. The two major parties. There's some third party like Libertarian and some Green Party that I'm not too sure. Okay, but anyway, those are just some small parties. But major is Democratic versus Republic. So Democrat versus GOP, and so we have all of the candidates picked out here. Picked out here, and because you may also be interested in total, like how much money GOP received, total how much Democratic Party received, is it total contributed, like those kind of information. Maybe you are also interested in collection, is it? So how can we do that if the original data didn't provide that information? So that's over here. We define the dictionary. Is it with the dictionary, you have the candidate and the associated party. Is it candidate and the associated party, and the candidate and the associated party? Is it? So we can manually create this dictionary. It's not too many records, is it? Because we only have kind of closing to a dozen candidates. So that's not much of work. And with this, is it? And over here, then you can use that dictionary to do some mapping. Okay, to do some mapping. So this is candidate name, is it? Candidate name. And here you provide the mapping, is it? Name to party. The mapping, okay, the dictionary mapping. And here it just shows, is it for a certain number of records, is it from that 123,456 to the other one. Is it? So anyway, so over here to list those mapping information. So for each specific record row, is it? And then you can know it's Democratic or GOP, is it? And once we have the mapping information, then we can add a new column, is it? Using the map, okay, using the map. And so this is going to be a new column, okay, for the original data set. And then we can do value counts, okay, total how many Democratic, how many Republican, okay. Okay, and then what the next one try to show. So then let's see what the, okay, so the data set, the data frame, so FEC is our pandas data frame. Data frame. So now we have that party column at the very end, is it? And here you have like a candidate name something, data and plus contribution, a lot of information, okay. And over here, what this part try to show is, and we want to know how many contribute more than 0, is it? So this contribution receipt amount, so this is the contribution amount. So you want to know greater than 0, is it? And the value counts, okay, value count. So here then it says, okay, for more than that, then you have this 991,000 something, is it? And you have around 10,000-ish that contribute, that basically didn't make any contributions. So we have this result, okay. And with this result, then over here, we do further cleaning because you may use the contribution amount to do some calculation, okay? So what over here we are interested, we are going to filter out all the records that doesn't make any contribution, okay? So over here, we only keep contributed ones for our records, okay? So basically over here, we apply the filtering, and then we update our data frame, and we get a glimpse of the data frame. And if you take a look at the very last column, yes, we did have the party column added, okay? And this one now it's already filtered out, okay? So all of those that didn't make any contribution taken off from this data set. And then next, let's see, okay. So this is regarding the original data frame, the above data frame, okay, we already filter out the contributed greater than 0 and the party. And then this is a candidate name. And we're going to do further filtering as we're only going to keep these 2 final candidates. One is from Democratic and one is from GOP, Republic, is it? So over here it says, okay, is in this list. If it is in this list, we are going to keep it, okay? So then we are going to assign it to a new data frame. We call it federal election macro, okay? Maybe it's macro edition. So anyway, in this new data frame, the candidate, we will only have the Democratic final candidate and the Republic final candidate. And we also get a glimpse of the information, is it? Okay, then next. So a lot of information. Then we can do the analysis. Okay, the first is you want to find the donation statistic by occupation and employee. Okay, so how do we do that? We do have the contribution occupation column, is it? And if you do value counts, is it? And then over here, we just pick the top 10, is it? Then you can see, okay, looks like retired people contributed the most, is it? And then it's that information request, attorney, homemaker, physician, is it? And so over here, it's list the top 10 donation by the occupation, okay? And then what next is, we also try to do some cleaning, is like over here, it's like information requested. It's a per best efforts information request or info, and all of those looks like we don't have some detailed information about their occupation. Is it? Because even though you request, you may not get a reply. So how about we say we just make it as not provided. And for the CEO, we also abbreviated to CEO, okay? And after we do this so this is another dictionary, is it? What we can do is over here, we provide a lambda expression, and this lambda expression is going to use this dictionary and dictionary based on its key. This is the key, is it? And here is the value part. Okay, and what this get, if you recall from previously, we discussed about dictionary, and over here it's just by default. If no mapping provided, then you just return whatever value you specify here. And here it says just use the original, okay? If there is nothing provided, the value part. Okay, so anyway, so this is just try to get the mapping. So this dictionary mapping, okay. And then for the contributors occupation, then you can do the mapping, okay, provide by this lambda expression, that then we update that contribution occupation column, okay. And then what next one try to show is the employer mapping, is it? And you may also have some not reply, is it? So we just use not provided so that we don't do some detailed categorization. Okay, we just generalize them as not provided. And the same thing, we provide that similar lambda expression, okay? And then we can update that specific column, okay? Okay, so over here is just we can use a Java dictionary to do some further mapping and cleaning work. And then this is on the original data frame, okay? Not the one with only two candidates. FEC, yeah, let's see. FEC, this is that FEC. FEC, okay, then we added a party. Okay, yeah. So this is that FEC. Okay, the FEC contains the information. We also have the party association added. So it includes most of the original candidates, the dozen one, not just the two final one, okay? Okay, with that one, let's take a look. So for that one, we did the pivot table here. So here you just try to do some aggregation. And if you recall, pivot table can help do the aggregation, is it? So the aggregation, the value part you pick is the donation amount, okay, contribution amount. The index is the occupation based, okay, and the column is going to be based on party. And if you recall, we previously said the pivot table is do some aggregation, is it? So aggregation, you always need to do something, is it? Do summation or do mean or do count, do size, something, is it? So here we do the summation. Okay, so then you're going to have the aggregated result, is it? And we store it to this by occupation variable, is it? And for this variable, we are going to do some further thing, is it? Further thing is, then if you recall, over here, the column, it should has two column, is it party? You have Democrat, you have Republic, is it? And over here, what we are going to pick out is you are going to summation by this axis. So this is by column, okay? So sum by column, is it by column? And you're going to pick what? So the two value added together, two column added together, if the overall value greater than 2 million, is it 2 million? Okay, if it's greater than, you're going to keep all of those records, okay? And you store it in this over 2 million from the aggregated result, okay? And then what over here we will see. So maker contributed more than 2 million, then here it shows, is it? So all of the contributors occupation, is it? And looks like attorney contributed a lot, is it? CEO contributed a lot. So, and we have all of those detailed information, is it? And you can, of course, do some further analysis regarding this. Okay, and then let's see. We can also do some plotting, is it, to help us better understanding, and that's more visualize, more obvious, is it? So we can do the plotting, is it? And the plotting use what? Use the bar plotting. Okay, the bar plotting is regarding that over 2 million. And from this result, is it from the result we can clearly see the most contributed is from what? It's retired. As you can see, it's far more than the other. Is it? And some is not provided, it's also quite a lot. And the third one is a homemaker. Okay. And you can also, and the attorney, is it? And you can also see the distribution, is it? Between Democrat and Republic, is it? So with this kind of visualize, we can get a lot of obvious information. Okay, so this is regarding the plotting part. And what is the next one? Let's see over here. Over here, we define some function. So this function is called get top amounts. Okay, so you plug in some group information, some key information, and the number information, is it? So on some data frame, you are going to call group by. And group by what? By whatever key you specify, is it? And using what? And you specify the column, is it? You're going to do the aggregation. So here is still do aggregation. And the aggregation based on what? Based on summation, is it? Okay, based on the summation, and what you are going to return? You're going to return the top and largest values. Okay, that's what this method does. Okay. Okay, and after you provide this, and this time we are going to do the group by on what? On the 2 candidate ones. Two candidate, the 2 final, the Democratic versus the Republic. Okay, and then we group by what? We say we group by the candidate name, that we only have 2 candidates. So basically you want to know, okay, Democratic versus Republic, is it? And on this, for this group data, then what you are going to do? We want to find the top 7 or the top 10 contributor, is it? And you are going to call what? Call this method that you just defined, is it? And what is the key? The key is the column you're going to be based on the group, is it? The group you we are going to do what? Using employee or the occupation. Okay, so that's what we are going to apply for this method, is it? This provides a group by, is it? It's a group by this column, is it? And this is, and the group by, the value is contribution amount, and the key can be changed, is it? So over here we can try, okay, the key is either occupation or employee, is it? And you can also select the top 5 or top 7 or top 10 contributor, is it? Get more detailed information. And the result is showed regarding this one, okay, the top employer, okay, country. And then we can clearly see that the between these 2 candidates, is it who the top contributor employers from, is it? And for Democratic, we can clearly see it's from the top one is retired, is it? And then the second one, self-employed and not employed, is it? It gave us the trend, is it? And for Republic, the first one, the number one is from some information not provided, and followed by retired, and then homemaker, is it? So it's different, okay. So this gives us a lot of more detailed information, okay. And then what next one try to show is, a lot of time for the political campaign, you also want to know the donation is from small individual donation or from like some large company or something, is it? You want to know that. Then in this case, we can use the concept called bucketing, is it? The donation amount. So here first, you provide the bins, the range between the bins, is it? And then we can call the cut. And the cut on what? On the contribution amount, is it? And here is the bins. Okay, here is the bin. And this tells us what? The bin. So, and previously, if you recall, for the cut method, is it? The cut method will give you what? Will give you like the bin. So between 0 to 1 or 1 to 10, 10 to 11, 100, 100 to 1000 something, is it? So give you each different category of the bin, okay. And once we apply that to our data, is it? Then we can categorize. So this is categorized data. Categorized data, is it? So for each bin, is it? For each individual record, then it gives you that contribution belong to which bin, is it? Which bucket. Okay, once we know that, so this is called labels, is it? We have that labels. Okay, once we have that labels, and for the two candidates data set, for the two final, the Democratic versus the GOP one, is it? And then we can call group by. Group by what? We use candidate name and also on what? On the buckets, the donation, the contribution buckets, the label we already know, is it? So you're going to do the group by based on these two information. And after that, and if you recall, after group by, you always need to do aggregation. Is it? Here the aggregation is to find the number of items in each category, is it? And then we do n-stack, is it? So to make our data more, make it wider, is it? Okay, and then here is the results if we take a look. Is it? So the result shows us, is it? Okay, so for the donation, is it? From the different buckets, is it? And then you can say, okay, make like $1 donation, $10 donation range, or under 100 donation range, is it? For each candidate, then you can kind of know the distribution, is it? And the big donor, is it? Those kind of information. So it's very obvious now, is it? Okay, and then what the next one try to show is, okay, so over here, after that we did the group with the candidate and the buckets, is it? And this time we don't want to know the number of within each category. We want to know the total amount. So that's why we do the summation. So here it shows the total amount within each category. Okay. And then what the next one try to show is we also want to know the percentage. Is it? So between these two candidates, we want to know within each bucket, each candidate takes the percentage, 90%, one person takes 90, the other takes 10%, or it's evenly split 50-50% within each bucket. Is it, how do we do that? So we have that bucket summation, is it? Then, so this is the original result, is it? And you do the divide, is it? Divide on what? You sum the two columns, is it? You sum the two columns. Okay, so that's the summation, is it? That's the summation. So 1. So axis is 1. And then you just use this one, divide by this summation, and use this one also divide by this summation, and we find the percentage. So that's what we also call it normalized summation. Okay. So it's quite clear, is it? And then with that result, the normalized result, and if you take a close look, you will find the last two buckets for the second column, we don't have the result. Oh. So that's why when we do plotting, we just exclude the last two. If you recall, is it the negative index is count from the end of a list, okay? We exclude the last two. Then we do plotting, still we use horizontal bar, okay? Well, it's pretty straightforward, is it? And with this bar plotting, it's also quite clear, is it? And between these two candidates, is it? And which bucket contribute more than the other, or evenly distribute something, is it? So it's quite clear. Okay, so this is about the bucket categorization. And then what next one we want to get donations studied by state. Okay, by state. Then in this case, we group by candidate name and the state. So this is the state column. Okay, after we have that, is it we can call the summation result. Is it we can do the summation. And after the summation, this is the summation, because then you have for each individual state, is it each individual state. And then we do n stack, and for nav value, we just fill with 0, okay. And you have this aggregated result, but we are not interested in showing all of them. We will just show, okay, if the summation, both column, the summation result greater than 10,000, is it? Oh no, 100,000. Then we are going to count that. Okay. So over here it shows the top 10 state. Okay, from the top 10 state, yeah, we can see it's is this Arkansas? I'm not sure AK is Arkansas, is it? Yeah, maybe it's Arkansas. And then Alabama, is it? And then Arizona. So here it shows the first 10 states. We didn't sort. We didn't sort the result, okay? Because if you think normally it's California, it should be the top because it has the most number of people, is it? So this is not a sorted result. This is just from the original we get the top 10, okay. But we just also we get the both add together should greater than this $100,000, okay, contribute money. So that's what we get. And then what next we try to find the same thing. We want to do the percentage that between the two candidates within each state, how the value is distributed, okay. Okay, so basically that's for this case study. So it's a not too comprehensive one, okay. And next week we are going to study the one that has more information. Okay, so that's all for today. So I will see you all next week. Bye.